Hello people of the internet, I've returned after getting my YouTube channel hacked. The infiltrators took over the channel and started streaming crypto scams, which got the channel deleted for violating terms. After a chat with Iris from YouTube Creator Support, I got the channel back and all of its glory. This all happened even when I used 2-key authenticator, which is crazy. Be safe out there. But enough of my chatter. Today we will code our very own aimbot for Csgo. The aimbot will use the origin vector, or the feet you can say. Then later we will use the bone locations to aim at the head. The reason for this is because using the feet position is easier, and we can easily change to use the head position afterwards. This tutorial will be divided into 2 parts. One which explains how we find the memory addresses and offsets using Sheet Onion, and the second part coding the aimbot. If you don't want to watch the first part, then skip to the coding bit, but as always, I recommend watching the first part for better understanding. Before we start any third-party program that interferes with Csgo, make sure to right-click on Csgo properties and add -insecure. Very important. Now you can start the game. Now when the game is started, you should get this evolve anti-cheat message. You have launched the game in insecure mode. Now this means we can use third-party programs in Csgo without getting banned. So open the console from here and type map ddust2. When you have joined the game, open the console again, type svsheets1 bot stop 1. Now use bot kick to remove all of the bots, and now we'll add 2 enemies. Why 2? Because one gets kicked at the end of the warm-up, so if you add 1 bot, you will only, or all of the bots will be gone. That's why we add 2. Alright, so finding the needed memory addresses. So we will have to find the local player, us. We'll have to find the entity list, which contains us and the other players in the game, so the enemies. For aiming at the enemies, we'll have to use the view angles, so the X and Y angle of our character. That will be located in the engine module. For offset, it will be the health offset, so we can determine if he's dead, and the X, Y, Z coordinates, so the feet position, and the team offset, and the dormant offset. The dormant offsets determines if we should be able to see the enemy's active coordinates in game and so on. So, and the team is, yeah, we don't want to aim at teammates, that would be really bad. Alright, when you have opened Sheet Onion, attach it to Counter-Strike. Now, to find entity list and local player, we'll search for our player. Type hurt me in the console. Search for 90. And repeat, so we just... I saw some values change, but we repeat this until we have just a couple of addresses. So I will use a hotkey. You can add hotkeys by going to the settings and hotkeys. Here I have a couple of hotkeys for changing values. So 60 health and 50. Now it doesn't seem like the addresses are getting any more or less, so let's browse the memory regions of them. So nothing happens here. Check the next one. The coordinates and so on are close to memory. So when we move around in game, we should see nearby values change as well. If we don't see nearby values changing, we can determine that it's not what we're looking for. So here values are changing when we move in game. That's good. If they do, we add them to the address list, because later on we will pointer scan for each one of them. So just add and add and add. If you might think it's the correct one, just add it anyway. It doesn't hurt to pointer scan for more addresses. Might take longer time, but you will end up in the right place. So here values are changing. Yeah, stuff is changing. But not what we're looking for. Stuff changes here. A lot of stuff changes here. Let's add it anyways. Alright, so we have added all of the addresses which have changing nearby values. Let's start pointer scanning. So I will go bottom up, you can go up to bottom, I don't care. For the max level it will be 1 offset, because the help offset is only 1 level deep. We don't need to search for more offsets. We'll name it, I'll just overwrite this one, so I'll call it player entity. Really? Still not done? Alright. Okay, so the first one. I've gotten lucky. Now, I know it's this one because if you take a look, the offsets are the same for all of these client.dloads. So we know that the local player and entity list are in the client module, and we know they use the same offsets, so this is looking really good. To check if it's the local player or the entity list, we will add them. So just double click. Let's check the first one. Remove the offset, so the pointer just uncheck it. And browse memory region and tools. Dissect data/structures. And here we go. So we have a pointer at 10 bytes. So here, this could very well be a player. Let's take a look if it's our friend bot Norm. RIP Norm MacDonald. Good man. Alright. We go here and look deeper at the offset 100. It's just a pointer. We can change it to 4 byte. It doesn't display the health, so this is not the entity list. Most likely. We'll check the next one, so go back to the pointer list. Remove the offset, browse memory region, Control D for hotkeys. Here is the first entity, which is us. If we look at the offset 100, that's 100 health. Now if we look at 10 bytes down, it's also a pointer, so maybe this one. Let's look at the 100 offset. 100. Let's go check with Norm. Sweet out to bunny hop. Just for time saving's sake. We'll hop our way. Heard him 75, so this probably is our entity list. Now, when we're here, let's open the sticky notes again. We'll add the address, which was here. Pointer scan result. This will be the entity list. And we also know the health offset, because the pointer scan, let's minimize that. For the pointer scan, when we search for our health, it's the offset 100. So, offset 100. Now, to find the XYZ coordinates, we'll just look for our coordinates in the game and compare them to the local player. Now, the local player, we can use one of these other pointers, because I don't think you want to use the entity list for the local player. You want to use a different address which only has the local player. Correct me if I'm wrong. But we'll take a similar address, so they don't look really similar. We'll take the first one. Hope it doesn't break. Copy the address. And now we have the local player and we have the entity list. So let's minimize that, or close that one down and minimize the rest. Now we can look at the local player. So browse memory region again, create a new structure. We have the offset. Oh, I don't know if this is that correct. We have the offset 100. We have the health. Now we need to look for the player location. So that will be 3 float values in a row, since it's a vector or a vector 3. It's a 3D point in space. And to find the coordinates in game, we can use the console again. So clear that, and we'll use the command get position exact. So here you even have the angles, or set, yeah. We have 160, 2369, and minus 119. If we scroll down memory lane, you can see that minus 119, 2369, and here's a pointer. Let's change that to a float, and it says 160. So I think we have found our player position. So for XYZ, we'll just type down 138, since it starts at 138 and it's 3 float values in a row, so we can just read 12 bytes instead of 4 bytes. For the team offset, we'll use clpdump1, and we'll get all of these nice things. So entity 1, as I said earlier. Now we just have to find the team number. So let me just skim through this with my eyes. Yeah, so here you can see iTeam integer, since it's an integer. It's the number 3. If we look at our entity list, add client.dll plus. There you go. Perfect. It is what? Now someone is calling me as well. Go away. I'm making a video. So, structures, define new structure. And now, finally, we have the entity list. We have the next player in the array. So, here is the health. Here is the player coordinates. And now we just need to find that team number. So, to do that, we'll actually have to find our team number. That should say local player. Can you open two windows at the same time? No, you can't. Alright, fair enough. We'll have to close the entity list down. We will browse the local player, dissect data/structures, and now we'll look for, let's just highlight the next offsets and change them to not hex but 4 byte, since it's an integer. Now we look for that team integer, which is a 3. So 3. Let's write them down here. So F4 and F8. Now when we take a look at the pdump, you have these team num and pending team num. They are after each other, so probably one of these ones. I don't think we need to look further in the memory, since that pretty much gives it away. No, I don't see any freeze. So let's use these two offsets, F4 and F8. Now we browse the entity list instead. So entity list, browse this memory region. There we go. So 10 bytes down for the player. This is not the entity list. There we go. Browse structures. Alright, so 10 bytes down. Now 100 health, there we go. We search for our F4 and F8 offset, which are here and not further down. We have 2 and 2. So since we know team num or the team num integer is the first one using our pdump, we can say that F4 is our team num. Now for the dormant offset, we'll just use r underscore draw order order models 2 for this ESP kind of stuff. And now we'll check if there are changing numbers. Let's remove that pdump. There we go. Okay, so now we're back. Now we're looking for the dormant offset, which is a byte in memory, and it's either 0 or 1. So when we see him, it should be 0, and when we don't, it should be a 1. So if we take a look in memory, here around, you might see that EC is changing when you see him and so on. That's because EC plus 1 byte is ED, which is the dormant offset. It's a bit weird since, well, we use 4 bytes, but the dormant offset is 1 byte, so that should clarify things. Now let's write down the last one, which is ED. Let's fix that one. So it's hex. And now we can find the view angles. Yay! Okay, so let's find those view angles that we want. We know that they are in the engine and it's a pointer, so it's a bit different from Counter-Strike source. But how we find the address is the same. So we look up at the sky, further as you can, and we search for -89 in float. So 90 degrees. And now we just do the opposite and search 89. Now we just repeat. So we have a lot of values, and to filter them out we can do a lot of searches between or when we move the mouse. So since it's when we aim down it's positive, when we aim up it's negative, we'll just increase or search for increased value along the way. So you can also search for unchanged value. Alright, so now we have 100 addresses. Let's just change some of them, or to check which one is valid. So I think only one of these addresses will actually change the view angle, or the Y view angle. So we can select, I'll start from the bottom. Let's change that one to 0. Oh, okay, so it actually is the one furthest down. So if you aren't as lucky as me, you just check all of these, so change them at a time to 0 and so on. Let's move there. Alright, so now it's 89. If we would change them all, they wouldn't change, they would go back to the view angle. Nothing. It's not a green address. So you would just go through them like this, and finally we would find this address. So if you change it, the view angle will change. Set it to freeze and you can't move up or down. Perfect. So now we have our view Y. Since it's not a static address, we can't just use this. We'll have to pointer scan for this. So instead of having the maximum offset value to 4095, we will have the max value 20,000, because the view angle offset from the client state is too big for the default maximum offset value. So change maximum offset value to 20,000. Otherwise, it will not come up. You will just have an empty scan. So let's call this view angles. Okay, so we're back and we have a lot of pointers. I said earlier that it would be the engine module, so let's look for some engine module pointers. And we have 2 of them. Now, we knew that the offset was large, so it probably isn't 9b8. if we freeze that, we still can't move in game. And if we add 4 bytes to the pointer and freeze, it should be the view X angle. So we have found the view angles. So 2D vector, I suppose. I'm not really used to having the Y value before the X value, but we have found the view angles with Y in front of the X angle. So we'll write it down. We copy the view angle address or the client state, and we'll just plus. There we go. Let's add some 0x. Now we have everything we want for making a very simple vector origin aimbot. Let's get right into it. Alright, so if you have watched the first Csgo external part, we downloaded my template that I've made for you. So if you haven't done that, go watch the first part. It will be linked in the description and so on. So download the template and open the solution. We do this to save time, and there is also some sample code for you to use if you want. So definitely go check the first video out. It's worth it. Alright, so here click on the program.cs and you should see my code now. Alright, now we don't need this part. We'll remove this part, and I think we'll keep the rest of it. So now we can code we can start coding our aimbot. First off, we'll create our memory, or no, not our memory class. We already have a memory class, but we'll create our entity class. So a data type which we can store player information. So right click on the template and add. Now new item, and it's a class. We'll call this entity. Remove the internal part and write public instead, because we want to access it from our program. In this entity class, we'll store the player health, the player team, the X, Y, and Z coordinates, the magnitude, and yeah, that's pretty much it. So we'll have a public int health and team. My bad. And I do not want to set up voice recognition. No, thank you. And we'll have some floats. So X, Y, Z, and magnitude. So this is pretty much it. We don't need to store anything else actually. So we can close that down and we can continue with our program. The memory addresses that we found out, we'll write them down. So go under the internal class and we'll create a region. Let's call this mem, short for memory, and region. There we go. Here we'll have a structure, so client, here will the local player be, and the entity list. So now we just copy and paste. Entity list, which equals now we have some engine. We have the client state. And we have the view angle offset. So, well, let's just write it here. So, view angles, which equals this. And for last, we'll write the offset. So, let's move the window. I didn't think of that earlier. Cons int health equals 100. Let's just copy paste for 4 of them. Change them to the according offset values. So team F4 and the doormat, which is ED. There we go. Now, when we have declared the memory addresses, we'll create our while loop. So this will be the loop which we call of the updating local player, the update entity list, and so on. We'll do it from here. So the main loop. In this main loop, something is wrong. What have I done now? There we go. So, while true, it always runs. We'll call our functions, which updates the player information and so on. So, to update player information, we'll have some global variables to store. The first global variable will be an entity, and it will be the player, so us, equals new entity. For the second global variable, it will be a list. It will also have the, we'll call it entities. We'll use the same data type to store information. There we go. So now we have our player, we have the entities ready to be stored. So for this main loop, to actually call any functions, we'll have to create the functions. So the first function will be the updatelocal, or method, you also can call them. So we'll have a updatelocal. Let me just bring that to the front. There we go. Here we'll take in the player coordinates and the player team. So we know if or where we are, and we know what team we are. We don't need more information than that, since we will use a hotkey for the aimbot, so we can just call it when we want. So we'll have a buffer for the reading part, so read pointer. Now we use the client, and we use the local player offset. So the client from the get module base. If you don't understand all this, take a look at the memory class I made. So here we have the get process, we have the get module base. Just skim through that, and this should explain that. So now we have some coordinates. We'll call them coords equals swedz.read bytes. We pass in the buffer from before, and the XYZ code offset. Now, since it's 3 floats in a row, we can just read 12 bytes. So the read bytes method uses pointer address, an offset, and how many bytes we should read. So we use the buffer pointer, we add the XYZ offset and we read 12 bytes from there. Now, since we have already read all of the free floats, we can just convert them now. So player.x equals now bit converter to single it is. And there you go. So we use the coordinate and we start from or we go from the start, which will be the first float. Now just to repeat 3 times for the different coordinates, but we'll have to read from the end of the float so we don't mess that up. We'll have to go in order. So here we read 4 bytes, we get a float. Here we read 4 bytes, we get the second float, and from 8 bytes we read 4 bytes again and turn them into a float, and then we have a 3D coordinate to use. So for the last value, that will be the team number. So now instead of 2 single, we'll use 2 ints. 3 bytes, and we pass in the buffer, and the team offset now we read 4 bytes since it's an integer, and we start converting from the index 0. So now we have the player coordinates and we have the player team. Now we're done with the local or update local method. Let's update the entities. So we update the information of all of the enemies. Update entities. First off, we'll clear the entities so we don't just add more entities to the list. And now we'll use a for loop. So int I equals to 1 because the entity list starts at our player. So if we use I equals 0, we would read in our location, and that would mess things up since we don't want to aim at ourselves. So we use I equals 1, and we use I is less than for easiest sake, we'll use the number 32. So we'll read 32 players. If you want to read 64, I think 64 players is the max. So if you want to use the max, just read 64 players instead of 32. And now we'll filter out the bad entities. So the dead entities, the entities which are not... Oh my, are you kidding me? Go away. Always. We'll filter out the entities who are not dormant. We'll filter out our teammates, so we don't aim at the teammates, that would be bad, and so on. So we'll create a buffer again, and we do read pointer. We use the client, and now we use the entity list plus I times 10 bytes. This is because the entities are 10 bytes apart, which you would have known if you watched the finding memory addresses bit or part. But the entities are 10 bytes apart, so we just add 10 bytes to the entity list and read each one of them. So for the team, that will be bit converter to int 32. So I don't read bytes. Not what? Buffer and health offset. Not the health offset, that should be the team offset. and we read 4 bytes, and we start converting from 0. There we go. For the dormant value, we will just repeat but use the correct offset. So instead of team, just use dormant. Hold on, we can't use that. We'll rename this to TM for team. So now we use the team offset. That's better. For the last value that we will use to filter the amount is the health points. So we can tell if they're dead, and if they're dead, we will not use them. Now just change that to health. There we go. If HP is below 2, now why not 1? Well, for some reason players, or they don't go to 0, or when they're dead they get stuck on 1 many times, so we'll use 2. I know there's a dead offset, but I'm too lazy to find that. You can find it on your own. So if you want a better way, use the dead offset, but HP below 2 also works. Not the best, but it works. If it is not dormant, and or he is our teammate, so team equals player dot team, we will continue the for loop. So by using this, we just skip to the next part if it's a bad entity. Now we know that it's a good entity, so we will read the coordinates of him. Read bytes, and like before, we will read 12 bytes since it's free floats, and we'll just convert them like earlier. So we can open up our void and copy this and paste, since we use the same variable. It's a local variable, so it's fine. For the players, it should not be player that we need to declare a new entity, so you can't just copy paste. That's not good. We'll create a new variable, so ent equals new entity, and we'll change from player to, or from player to ent. We don't want to change our local player, that would be devastating. But the entity's team will be the team that we and dot health equals to HP. And now, before we add this entity to the list, this global list, we'll have to add or create one more method, which will be calculating the magnitude between two 3D points. This is fairly easy stuff. I think I learned this in 8th grade, so float called magnitude, entity, let's call it E, because we will repeat, or we will use that variable quite often, so we'll return a float, which is casted because math.square root returns a double. We'll use the math.pow e.x to the power of 2 plus, and now it's just copy paste. And just kidding, it's not just copy paste. We'll have to do the entity x coordinate minus the player x coordinate to the power of 2, because it's delta x, or it's a delta magnitude. Player.y plus and the last z axis minus player.z, and I think that's it. There we go. So we create a new line using the x and y axis. So you get the hypotenuse or hypotenuse of that, and we use that to we'll create a new line directly to the player, which is the distance, and with that distance it becomes the base of a new triangle which has the height of the z-axis. This is just a short way to write it in one line. Alright, so we have the calculate magnitude. Now we can add the magnitude between us and the entity. For that, we use the magnitude value and we use calc magnitude. So entities dot add entity. There we go. So now we should be able to just call this method, and this global list should be updated with new and active coordinates for alive or enemies. Alright, so the last method, the aim method, it will take an entity. So we aim at an entity. We'll call it ent for short. So first off, we calculate the x view angle. So x, we'll use delta x, which is at ent.x minus player.x. We'll use the delta y, and to calculate the x value we just use math.atan too. We have to cast it as a float, since math.atan is or returns a double. So in the math.atan2 we'll pass in the delta y and the delta x. To convert it from radians, because atan2 of course returns radians, we'll just convert it to degrees by doing it times 180 divided by math.pi. There we go. So we have the x angle. Now we just have to calculate the y angle. For that we'll use the delta z, which equals, you guessed it, ent.z minus play.z. Since to calculate the angle on the y-axis, you will have to need a base of that triangle. Now you can't just add whatever, you need to take the hypotenuse of the x and y axis, which we did in the calculate magnitude. So it's the same stuff but without calculating a 2D vector. Here we just get the distance, which is a 2D vector, but you get the point. It's not So distance, oh, never mind, we don't get a 2D vector from the magnitude, that's just a float. So we use math.pow delta x and plus delta y to the power of 2. So we get the distance, and with that new base of a new triangle we can calculate the angle using the z-axis. So float y equals, and we have to use a minus sign before because it's inverted. You saw that we searched for -89 when we looked up, so we just invert it by putting a minus sign in front. Math.eta2, now delta z and the distance. So here we have the y value and or the height of the triangle and the base of the triangle. And convert it to degrees, of course. Now, since it's a pointer, we'll have to use the buffer again. So read pointer, and now we use the engine and not the client. We add the client state. Now we write new bytes, so we write the new calculated values, which will be these ones just converted into bytes. So we use the buffer pointer, we use the viewangles offset, and we write bit converter, and now we use get bytes for the first time. Pass in the y, and we're done. Copy, paste, change this to x. But remember, we will have to add 4 bytes because it's 2 floats in a row, and the x value is after the y value. So we just add 4 bytes to this view angle offset. I also showed this in the finding addresses bit, so if you're confused by this, go back and take a look at it. Now we have all of our methods. Let's call them in our true while loop, but we also want a hotkey to press to use the aimbot. Otherwise it would be very painful to use this aimbot. For the hotkey we'll use get async key state. DLL import, and it's a string user32.dll. It's a static extern short get async key state keys v key for virtual key, I suppose. Hover your mouse over the keys part, show potential fixes, and click the using system.windows forms. For the DLL import we also need to hover over that and show potential fixes using system.runtime.interop services. There you go, so it got added up there. Now we can check for hotkeys as well. So if get async key state keys dot, I will use the X button. You can use whatever button you like, the X button, the O button, numpad button, but I will use the X button since it's on the mouse, and holding that is much easier than anything on the keyboard. So if our preferred hotkey is down, we'll start updating the local position. We'll update the entities we'll order the entities by magnitude. So magnitude, there we go. So this is the closest one. If there are any entities, we will aim at the first one in the list because we ordered it by magnitude. Because we don't want to burn our CPU, we'll use thread or a thread.sleep. So go up here and type using system.threading. Now we just sleep for 1 millisecond. I think we're done. So let's start the game and test it if it works. Okay, so now I have created a local server and let's test it out. So start. If you're having problems, change the project settings to 86 since it's 32-bit. But let's take a look. And it seems that we have something. Okay, we have a working aimbot. Let's take a closer look.
Let's get this over with.
Nice. So this is the origin vector, which means we're using the feet, but we're also using our feet. So the point is somewhere near the head. So it's not, or the 3D coordinate is not on the head, but it's close. If you want to make a good aimbot, you would want to use the view vector. So where our camera is at, we have to use that, and we'll have to use the head bone, or yeah, the bones, which have 3D coordinates, and the head has a head bone. Yeah, which means if we find that location, we can use the head coordinate to aim at. I will show this in the next tutorial. This one has gone on for too long anyways. And if I would start by looking for the head bone and so on, people would not be able to follow.
What's your status?
But
We're clear.
if it all went good, if you liked this video, be sure to subscribe so you don't miss the next part where we use the head offset or the head bone and stuff like that. And drop a like, comment. I will see you guys in the next tutorial.
This is our day.